All right, we're back with chapter 9 and 10 practice problems video. We're going to do one problem from chapter 9, one problem from chapter 10. I'm going to try to keep this as short as possible since I know your lecture video is a little longer this week. So the chapter 9 problem we're going to look at is creating a Pareto diagram. The idea here is that if there's a number of different observations and things you do in a business, then likely some of those things need to take precedence because a few products might be the bulk of your business, or processes or services you provide might take up a lot more frequency. So we can try to help determine what those are by evaluating them with a tally sheet or a check sheet, and then creating a Pareto diagram to show that. Now, I will say that for this particular chart that we're going to use, the Pareto chart, older versions of Excel will not have one of these. You will need, it's listed under histogram to the right, but it's Pareto chart right here. You will need that. So ideally, you're using Office 365 because it's free. If you haven't downloaded it, go to the IT portal on the Go NSU website and install Office 365. Again, it's free. You just log in with your NSU student ID and you get all the latest updates for all of Microsoft Office. If you're not, if you have an older version of Excel and you don't see this, ideally you would then go to the computer lab on campus. The Broken Arrow and Tahlequah campus are open 24/7, but hopefully you can use that Pareto chart, because you will need that for full credit on making the chart. You can make it work with a histogram, but you have to rearrange the data to make it work. You can make it work with a 2D column chart, but again, you'll have to rearrange the data. So ideally, you're using a Pareto chart for this. All right. So we're going to look at all of the tickets issued and count the frequency of each. Now, if you were doing this by hand, you would say, okay, excessive speed, check, and you would draw a little tally mark, right? Expired inspection, check, and you would do this until you finished counting up all of them, but you're just counting the frequency of each, right? So I'm going to show you a quick and easy formula to use that we have not used yet. Some of you actually have used it, even though it wasn't necessary. But I appreciate you took the extra effort because it would definitely made some of the previous homework easier if you knew how to use it. But I typically introduce it now. The formula is called count if, meaning I want you to count the frequency if certain conditions are met. And the certain condition is going to be if parking violation is found in this group, I want you to count it. If not, then it won't count it. Excessive speed is found in this, I want you to count it. If not, it won't count it. So that's what we're telling Excel to do. So count if, right here, the range. The range is going to be this section right here, comma, the criteria you want to look for is this item specifically. Now we click on the cells here because if I could type the words out, if parking violation, and if you're going to type words, you have to put them in quotation marks. So I would have to type it like this, parking violation, and that'll work. But if I misspell one on accident, it won't find it. So that's why clicking the cell is probably the way to go, because if I accidentally misspell it, it just will not count it. So instead, we're going to count if in this range, I find this criteria. And if I was to go back here and lock in these cells when I created this, then I could just copy this formula down. So let's do it from scratch by locking them in instead. Count if this range, F4 to lock in that range, comma, this criteria. Close parentheses, enter, I get 10. And if I drag it down, I get 10, 5, 3, and 2. Perfect. Now, if these were not listed in frequency from highest to lowest, I would need to cut and then right-click, insert cut cells to move them around to arrange them from high to low, because part of the Pareto diagram requires us to arrange from high to low. And then we're going to look at a couple more things in this box. One, we want to sum all the frequencies, and we see 20, and we also see over here ticket info there was 20 of them, so we know that that's good. We didn't miss any. This is a good way to make sure that you had your range correct. If you didn't lock in these cells and you copied it down, well, then your range is going to move to here, then your range is going to move to here, then your range is going to move to here, and you're going to leave out several cells and your answers won't be correct. So again, make sure you lock in your range if you're going to copy and paste it and not just do the formula 4 times in a row. Cumulative percentage, we have to start by looking at the percentage covered by parking violations, which is going to be this divided by this. And then we want to list these in percentage form, which yours should still just do by default. I just set up this form, so hadn't done the formatting yet. Cumulative percentage. So as we look at each infraction type, we're adding more and more percentage to it. So this isn't just going to be a percentage of this divided by this all the way down. Instead, once we do our first one, we then are going to add 50% plus 5 out of 20. So the one above it, and then add to it the additional percentage. So 5 out of 20 is 25%. So I should see 75% here, and I do. Now I can copy that down. But again, you have to do it 2 formulas, this divided by this to start, okay? Then the percentage above you plus this divided by this. Now that I've done that, I can copy it down. Oops, I didn't lock in F8, the out of 20 part. All right, now I drag it down. So I should see 100% on the bottom right if I've done it correctly. And you can see here that 2 of your infraction types take up 75%. The Pareto principle would say that 80% of your volume is covered by 20% of your task. Well, that's true if you have a lot of different ticket types. Because there's only 4 of them here, you can see that, half of them take up 75%. But if there was maybe, 12 different ticket types, you would see that, roughly 2 or 3 of them took up 50 to 75%, or sorry, 75 to 80% of all of them. And the more types of observations you look at, the closer you get to that that phenomenon where it's approximately 80-20. So let's now insert a Pareto diagram. For that, we want to highlight just the infraction types and the frequency numbers only. We're going to go to Insert, and we're going to insert a Pareto chart. If we do that, we're going to put it in the box that I've got outlined on your template. And then please be sure to edit the chart title. If it just says chart title, you're missing out on some points there, because part of presenting data is making it understandable. So this would be, we call it a Pareto diagram of traffic infractions. Some kind of title, right? That explains what's going on. And then this one's done. That's chapter 9, solve problem, and you only have 1 assignment this week on that. Pretty much that covers all of it. Now let's look at chapter 10. Several more steps on this one. We have 5 days where we took samples, and each of these needs to be averaged out. Now, some of the problems you'll have, they're already been averaged out. So we have the mean of sample 1, and we'll have the range of sample 1 already given to us. But I want to show you how we would arrive at those numbers. So the mean of this one right here would be the average of all my sample 1s, okay? And then the range is going to be the highest one of sample 1s minus the lowest one of sample 1s. Okay, so that's going to be, we could say the max of these values, close my parentheses, minus the min of those values. Oops, didn't close my parentheses. So 9.8 is the lowest, 10.2 is the highest, 10.2 minus 9.8 is 0.4. So now we've got the mean and range. Now, unfortunately, if I copy this down, it's going to average out down with me, right? Because they're not arranged in the correct manner. So I'm going to have to do the average of these cells separately, because this isn't set up in the proper way. I should have probably had them lined up, transpose those. We could have done it. So let's average out each of these. And again, for most of your work, this is going to be done already for you, but I want you to see where these numbers come from and why we have a, why this is called X double bar. So X double bar would say, this is the mean of your samples. So these are your samples, and samples are X's, and a bar over the top of it would say the average of your samples, the mean of your samples. X double bar would say, I've got the average of all my samples. So I need the mean of the means, the average of the averages at the bottom here. And now I've got X double bar. This is X bar, this is X bar, this is X bar. All these are X bars. This bottom one is X double bar, because it's the mean of these 5 means. And I'm going to use that in my formula down here to find my control limits. Now I'm going to go to the range and finish out the min maxes here. So let me do this. I'm going to copy this formula in and then just correct it by going here and changing the I to a J on all occurrences. And then change this one to a K. And then change this one to L. And then change this one to N. All right, now I need the average of my ranges. You can see down here on the UCL and LCL Rs that we need the R bar at the mean of our ranges. So since these ranges were not averages, it's just a single bar over it. So we're going to average out, I'll just copy this over, average out the 5 cells above me. We get 0.520. All righty, so what does this mean to us? What we're looking for is, by averaging out all of the ranges and the means, we can start to plug in those values into simple formulas to determine what the highest and lowest range should be. We have actually collected 20 total sample observations, 20 observations here. And so because of the number of observations on this, we can be pretty satisfied that we're going to get a decent evaluation of what our upper and lower control limits should be. And then we can look and see, are any of these individual means outside of those control limits? And so from this chart, we need to not look at the total observations, not look at the total samples, but each sample mean here, this 10, how many observations went into this sample? And the answer there is 4. So there's 4 observations per sample. So our N on this problem is 4. The number we use for N has to do with the number of observations in each sample that were averaged out to get our sample mean. To get the 10.0, we used 4 observations. So N is the number of observations. We know the N is 4. And now we have to use control chart 10.3 from your book in chapter 10. And this tells us what values we should use for A2, for D3, and D4. What do those mean? Well, you just plug them into these formulas, and they help us determine that. So 4 observations, I look for number of observations in a sample, 4, and the factor for chart A2 is 0.73. Okay, so let me 4 observations. My factor for A2 is 0.73, D3 is 0, and the upper control limit for range is 2.28. So I'm going to use these values, 0.73, 0, and 2.28, and plug them into my worksheet here. So you'll need to be able to look up on that chart, again, it's 10.3 in your book, and find those values. So let's go back to our Excel problem, and I know that 0.73 is going to be my value for A2. D3 was 0. It's so low that it could go all the way down to no range at all. And then D4 is 2.28. Now that I have those values, I can look at the upper and lower control limit for the X double bar. So for the X bar chart, the highest and lowest will be based on this formula here. I'll make it a little bit bigger to see it. So for upper control limit, we need the X double bar value, which is this value right here, the mean of your means. And we need to add to that A2 times the range, the mean of the ranges. So that formula is going to be equal to X double bar plus A2 times the mean of the ranges. Hit enter, and we get 10.420. That's the upper control limit. Now the lower control limit is nearly the same formula, except we subtract from it instead of add to it. So the mean of our means minus A2 times our range, and we get 9.60. So is this process in control? What I'm looking for is, are any of these X bars higher than 10.42, or are any of them lower than 9.66? If so, then it is out of control. Otherwise, if they're within that range, then the process is said to be in control. So 10.42, 3 decimal places here. 10.42, all of these are below 10.42. 9.66, all of these are above 9.66. So they're all within that range. We could say that is this process in control based on X bar, yes. Okay. Now let's look at our ranges. On the range, we use this simple formula, D4 times R for the upper control limit, D3 times R for the lower control limit. So D4 is 2.28, R bar is 0.52, I get 1.186, and then lower is 0 times 0.52, which is 0. Now, are any of these ranges higher than 1.186? No, they're all below that. Are they all above 0? Yes. So based on R bar, yes, and then based on R bar, yes. The process is in control because it's within those ranges. And that's it. All of this that we did initially, I believe most of the problems you're going to see, this is done for you. But if you needed to figure out the X bar for each of these samples, you would average this one out, average this one out. Range, it's the highest minus the lowest. So if you have to do that manually, that's how you would do it. Otherwise, you can skip that portion because you're probably going to be presented with just this type of chart to begin with. Once you have that, average these out, and then fill in the values from your table 10.3, and then follow this formula for upper and lower control limit of each type. All right, that's it for chapter 10 as well. So we'll see you in chapter 11.